guys. So today we are going to continue what we've been talking about. So your journal for today is to tell me what is the difference between a repeating decimal and a terminating decimal. So we talked about this yesterday. So you should have examples of both of these in your notes. So when we answer a question, remember we repeat the what? The question. So you can say the difference between a repeating decimal and a terminating decimal is, and you could tell me that. So you could do that multiple ways. You can just tell me one difference. Think about what the words mean. What does the word repeating mean versus what the word terminating means? You could give me an example of each of those. You have examples from yesterday that we talked about, but you have 5 minutes to tell me the difference between a repeating decimal and a terminating decimal. Go. Make sure you write out the complete sentence. So you're telling me the difference. You have 1 minute left. Make sure you start your sentence with a capital letter. You end it with punctuation, most likely a period. All right, time is up. So let's complete our sentence. Okay, so what do we got? What is the difference between a repeating decimal and a terminating decimal? I'm assuming somebody's sharing right now. The difference between a repeating decimal and a terminating decimal is, well, what does the word terminating mean? What does terminate mean? It means to get rid of. It means a lot of people said to kill, to make it go away, right? It ends. It's gone. Okay? So a terminating decimal has an end. Whereas what does a repeating decimal do? It repeats, right? It keeps going and 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 going. My 4th and 8th period, I think y'all got to hear me sing. I don't think 3rd period got to hear me sing. And Mr. Ramsey, I apologize that you have to hear me sing, but remember the song. This is the song that doesn't end. Yes, it goes on and on, my friend. Some people started singing it, not knowing what it was, and they continued singing it forever just because this is the song that doesn't end. Yes, it goes on and on, my friend. Some people started singing it, not knowing what it was. They continued singing it forever just because this is the song that doesn't end. Yes, it goes on and on, my friend. So y'all get it? It keeps going and it keeps repeating and looping and it never, ever, ever stops. So the difference between a repeating decimal and a terminating decimal is, and you could word this different ways, right? So my way is not the only way, but a repeating decimal keeps going and a terminating decimal ends. There are multiple ways to word that, right? A repeating decimal goes on infinitely, right? A terminating decimal terminates, okay? So an example might be, so a repeating decimal would be like 1/3, right? Which is just 0.3333333333333. It keeps going. Or we could write that as 0.3 with a line over it to show that the line is what's repeating. Okay? A terminating decimal is one that ends. So for instance, 3 over 2. If you type that in your calculator, you get just 1 over 5. Nothing comes after that 5, that's it. It's just 1.5, we're done. So a terminating decimal ends, and a repeating decimal keeps going and going and going and going. Okay? Very good. All right, so this is from yesterday. Okay, you guys should know this. You should have this. Mr. Ramsey is going to pass out this note page to you really fast. Here's just another copy of it so that you have it. Okay. We have terminating decimals. We have repeating decimals. Those are all rational numbers. Okay. A number is irrational up here in the orange if it is non-terminating, if it is non-repeating. So there's not a pattern, but it keeps going. It doesn't end, but we don't know what's coming next. It's not repeating a 3 over and over and over again. It's not repeating 58, 58, 58, 58, 58. It's just random numbers. 1, 4, 1, 5, 6, 7, 9, 11, 2, 6, 0, 1, 5, 3, 2, 1, 0. It's just numbers. It keeps going. So irrational are the funky ones. They're the ones we don't know what's going to happen. The rational ones are the more predictable. There are whole numbers, our integers, our fractions, our repeating decimals, our terminating decimals, or our perfect squares. When I put in a perfect square, I get a whole number. Square root of 4 is 2. Square root of 100 is 10. Square root of 36 is 6. These are all up on the board over here in green and blue. You can see them. Those are our perfect squares. Okay? So now if you can pause it, we're going to play this video, but in a different tab. I'm not going to play it here on my video, but it's on a different tab. I'm going to have Mr. Ramsey play this video for you, and then you can come back to my video. Okay? So pay attention, please. This is important for your assignment. All right, so hopefully you watched that video. Hopefully you got a better understanding of rational and irrational. It showed everything we've been talking about. Okay, so now I want to go through this, and I want to talk about which of these numbers are rational and which are irrational. Okay, so this first one, 0.3333, and what's over that 3 at the end? What does that line tell us? That it repeats, right? So if it's a repeating decimal, that's rational. And we know that because it is a repeating decimal. Okay? What about the next one, square root of 4? If you type that into your Desmos Scientific, what does that give you? If you look on the board, what is the square root of 4? Square root of 4 is 2. 2 is a whole number. If it's a whole number, what is it? Rational. We know that because square root of 4 is a perfect square. Okay. Well, what about the next one? Square root of 2. If you type that in your Desmos now, you're going to get this 1.414213. Is there a pattern? Do we know what number is coming next? Is it predictable? No, it's not. I have no idea what's about to happen. Okay? So here, it is a non-perfect square. Okay? Square root of 2 gives me a number that is non-terminating. It doesn't end. That dot, dot, dot tells me it keeps going. But it also doesn't have a pattern. It's not repeating. It's not 1.4141414141. It's some random numbers. I don't know what comes after that 3. I could guess, but I don't know. So that's what makes it irrational. Now look at this next one. 1.414213. It's very similar to the one above, but what's missing? Does it have a dot, dot, dot? Does it keep going? No. So this one is rational because it's a terminating decimal. It ends after that 3. That's it. It stops there. Okay? All right. Pi. This should be an easy one. What do we know about pi? Keeps going and going and going. Y'all know I am now obsessed with this website that has all my digits of pi. It's like the coolest thing ever. Just keeps going and going and going. Here it starts at our 3.14, but then it's just going. We don't know what's coming next. So pi is our most well-known irrational number. It is non-terminating and non-repeating. There is no pattern, and yet it keeps going forever and ever and ever and ever and ever. Okay? What about the number 11? What type of number is that? Number 11 is several things. It's a whole number. It's an integer. And it's a counting number or a natural number. These are all part of your vocabulary. Okay? Well, if it's one of those, that's a predictable number, right? There's nothing funky or weird about the number 11. It's just a number. So if it's a whole number, if it's an integer, if it's a counting number, if it's a natural number, it's rational. Okay? That's just a number. 1/7. There's 2 giveaways here. One, the definition of a rational number. We come back to what y'all have above here. Oops, too far. The definition of a rational number right here. A rational number is a number that can be written as a fraction. Well, 1/7, that looks like a fraction to me. So if it's a fraction, it's a rational number. Okay? We also notice, what does that line mean? That line means it's repeating. So this would be 0.142857142857142857142857, and it keeps going and going and going and going and going. So not only is this a fraction, done, that's all you need to say. But we also show that it is a repeating decimal as well. Okay, so as always, I talk too long, but this is what you need to know. You need to be able to distinguish the difference between a rational number and an irrational number. You need to be able to recognize when it's a perfect square or a non-perfect square. You need to recognize when it's a repeating decimal or a terminating decimal. And you also need to recognize when it's neither of those. So when it's non-terminating and non-repeating. Okay? Your assignment that is going in the grade book, your first assignment for this unit is on Schoology. There's a delta math, rational versus irrational, 228, that's the date. Okay? It is quick. You should be able to finish it before the bell. Go ahead and get started. When you are done and you have made a 100, then you may pack up and clean up and have a great weekend. I will miss you. I love you. And I will be back on Monday.